In this video, we are going to learn how to solve a linear programming problem using the graphing method. This particular problem is in a word problem format, so first we will translate that. On your birthday, your rich uncle gave you $19,000. You would like to invest at least $9,500 of the money in municipal bonds. So I'm going to let X represent the amount that I put in municipal bonds. And if it's at least $9,500, then that would be greater than or equal to $9,500. And then it says that those are going to yield 5% interest. So I'm going to put that down here for just a minute. And then it says that I want to invest no more than $4,000. So I'll let Y represent that next investment, which is Treasury bills. No more than $4,000 would mean less than or equal to $4,000. And it says those are going to yield 8%. Now, keep in mind, earlier it said that the uncle had given us $19,000, so you also know that if you add the amount invested in your municipal bonds plus the amount that you invest in your treasury bills, that total is less than or equal to $19,000. And so those produce what we call constraints, and we're going to actually graph the constraints. So linear programming problems, they have constraints. That is what we will graph. And then we're being asked to either maximize or minimize something. And in this case, it says how much should be placed in each investment in order to maximize the interest earned. So if we are wanting to maximize our interest, and they tell us to assume simple interest applies, then we know that with our municipal bonds, if they're paying 5%, we're going to multiply the 0.05, which is the decimal for 5%, times the amount vested, which is X, times, we're just going to look at 1 year. And then we're going to add to that the amount of interest that we earn if we invest in treasury bills. So it told us that paid 8%. So the decimal would be 0.08 times the amount invested, which would be the Y, and also times 1 year. Now, you do not invest this objective function. So that is what we'll use at the end. Okay, so as I get ready to graph my constraints, doesn't matter which order, I'll first start with the X is greater than or equal to 9,500. I am going to scale the graph. Each unit will represent 1,000, so if X is greater than or equal to 9,000, so that would be 1,000, and I'm going actually up to 9,500, that would be right here in between the 9 and the 10, so I'd have this vertical line, and then greater than would be shaded to the right, just like this. I'm just going to kind of shade one direction. All right, then my second inequality or constraint said Y was less than or equal to 4,000. So again, using each line representing 1,000, this would be the line Y equal 4,000. So less than or equal to that would be below it. Now we're going to be interested in where these overlap. So you can see right now where the red and the green are overlapping. And then I have a third constraint. And since that third constraint is an actual diagonal line, to make it easier to graph it, I'm going to actually get the Y by itself. So I'll subtract X on both sides. So that leaves me with Y is less than or equal to negative X plus 19,000. Okay, so when I go to graph this, my Y-intercept is at 19,000. So that's on the Y-axis. My slope I'm going to think of as -1 over +1. So that means I'm moving down 1 and to the right 1 to find other points that are on that line. And you want to do that until you hit or cross your x-axis. So we'll go all the way down here. And of course we hit that at 19,000 as well. And that inequality said less than, so we would be shading below that line. And I'm going to purposely, I'm only interested in where it overlaps what I've already shaded. So since it's in black, I'm just going to shade that part. So you'll notice we get this triangular region here where all of our shadings are overlapping. Now, in order to maximize our interest, we have to find the corner points of that shaded region. And so I know down here where the green line was, my x value was 9,500, and since it's on the x-axis, the y value is just 0, so that's one corner point. Here, as I mentioned, I'm going to hit at 19,000, so the x value there would be 19,000. The y value is also 0. And then if I look at here, I know that x value is 9,500. If I've graphed it accurately enough, I can probably read the y value off the graph, and even if I haven't, then I could actually calculate it, and it would also be 9,500 because we know together they had to add up to $19,000. So those are my corner points. Now, in order to find the maximum, we're going to take each corner point and we are going to plug it into this objective function that we talked about earlier. So when I take the 0.05 and I multiply it by 9,500, and then I take the 0.08 and I also multiply it by 9,500, that is going to give me a total of 1,235. Okay, so now I'll take my next corner point. So I'm going to multiply 0.05 times the 9,500 plus the 0.08 times 0, and that is actually going to give me a total of 475. And then finally, I'm going to take the last corner point, and I'm going to multiply 0.05 times 19,000, plus I'm going to add 0.08 times 0, and that is going to give me a total of 950. So if I'm maximizing, that means I should be choosing the largest. So I would say my maximum income in this case is the 1,235. And then they want to know where does it occur. And so you always write it like an ordered pair. So in that case, the x value was 9,500 and the y value was also 9,500.